Wait, both are going.
Yeah, that's why I'm recording. All right. So here is the question on the 13. We took the quotient rule, and now we have to combine like terms. H prime of z equals sine of z plus sine z cosine z minus, plus sine of z. Yeah, these are because you distribute. Yeah, you're multiplying. Right here? Yes. Plus sine of z. That would be a plus, which would make it a minus cosine z, sine z, all over 1 plus cosine z squared. All right?
2 sine z over 1 plus sine z squared.
Yeah, when you cross off like terms, because they're opposite, you end up with 2 sine of z over 1 plus cosine z all squared. Okay. Rachel?
Could you remind us, Kylie, what's going to be on this one?
Yeah, 3-1 to 3-3.
You did, like, you did for...
That'd be on the quiz?
No,
Oh yeah, maybe later I will. Which one? 15 to 19, and then we'll move on.
15 to 19.
What? 15? All right. Jessica, how'd you do number 15? You didn't. Remember, quiet please, this is going to affect a lot of you on this next step. I said you could do these one of two ways. One way is you can simplify before you take the derivative. I do that a lot with trig functions. Rachel? Yeah, I would. What's 1 over sine?
Cosecant.
And 1 over tangent? Now you're working with a product instead of a quotient, which I know it doesn't matter in the long run, but in the short run, sometimes it's easier to work with if you just look at it as a quotient. So I have g prime of x. What's the derivative of cosecant? Negative cotangent of x, cosecant of x. And you multiply that by the second one, which is cotangent of x. And plus the product rule is you always add. And what's the derivative of cotangent? Yeah, negative cosecant squared of x. Pretty nifty. You can factor a cosecant out of both of them. Remember, you're factoring to try to simplify it. And when you factor, all those Pythagorean identities come in. The sine squared plus cosine squared equals 1. The 1 plus tangent squared equals secant squared. And the 1 plus cotangent squared equals cosecant squared. So this is the cosecant of x. Negative cotangent squared of x minus cosecant squared of x. That doesn't get me anywhere really, so I'll just leave it like that. I could if I wanted to, but I don't. So I won't. Nice! A book answer. What do they have for a book answer?
Well, they changed cosecant. No, they changed cosecant squared, and then they got it down to 1 plus 2 cosecant squared.
Sure, it's a Pythagorean identity. But it doesn't get you anywhere as far as solving. Okay? So, that was pretty nifty. So after having done 15, doing 19 shouldn't be that difficult. I did? Excellent. On every one, you have a choice of simplifying or taking the derivative. So Kylie, what did you do? Did you consult with your note card first? Oh, well, what's cotangent? Do you remember? Well, that's the derivative, but what's the definition of cotangent? And what's the other definition? Yeah, cosine over sine. Excellent. Anybody knows anything fun about that one? Some of it's just remembering back in the day your trig skills, dusting them off a little bit. So now I can take the derivative of cosine, which everybody in the room knows is what? P prime of x equals negative sine of x. Excuse me? It wasn't easy, it's just different. You can't judge difficulty by length of time. No, No, you can't. Okay? I think we're ready to start in on it. Are you guys ready to start?
No, we should just
Do it.
We are going to review the trig function rules now. Who?
I didn't ask a question that involved a person.
Why didn't I hear what you said? So I was trying to be polite. What'd you say?
I said we should review this other thing that this one.
Yeah, we will later. All right, we got to finish this up. Oh, I forgot that doesn't work.
Aha.
All right. All right, here's where we left off. Go ahead and jot this one down. This one might help because your next quiz after Friday, after tomorrow, will be over 5 for 10 or 10 for 10 over this section. That'll be next week. Something like that. So, 22 is where I'm starting. Is what? That is a theta. And just like we do with the cosine, we can do the same thing with the secant. You can do the quotient rule. When you do the quotient rule, don't forget the derivative of secant is secant tangent. And the derivative is, yeah. I want you to write this down in case I ask you this question again. Great! Anyway, the derivative of secant is secant tangent. And the derivative of 1 plus secant is just the secant tangent because the derivative of 1 is 0. So we're using the constant rule and the trig rule of taking the derivative. Now, while this looks like it's going to be very difficult, it's actually not when you start multiplying things out. Okay? That's the biggest thing, is the fear factor when something kind of expands on you with trig. It's very common in the trig when you're taking derivatives is to have something expand like that. Okay, that's just because every term has a minimum of 4 letters in it for trig functions. So, now you just multiply everything out, making sure you keep the terms together, the secants and the tangents and the secants. That's just algebra manipulation with that, and recognizing which one works as far as, crossing things off. And when it comes to simplifying, don't try to use a lot of identities unless you have an end purpose. In other words, unless you're trying to solve something, or unless something is obvious. Like, don't start going with Pythagorean identities. Sines and cosines and cotangents and tangents we talked about, you can do that. But this one, everybody see something you can cross off, I hope? Yeah, the secant squared and tangent, they're opposites. Okay? So today is just more of a review, a reminder about what is how the trig rule kind of works with different definitions and identities. I think that's your final answer. I think that's it. Actually, it isn't that difficult. It looks difficult, but it's actually not. Hey, how are you? Yep.
Okay, so in the order of like your
No, not when you're multiplying. Only when you're subtracting.
yeah. Like you want like negative secant plus tangent minus 2 cosine. Like
No, it doesn't matter. Okay? It only matters when you go to solve. I think this next one is going to be a nice reminder to get your identity note card out. If you don't have an identity note card, is it this one? Yeah, it's this one. Then this problem, if you don't have your identity note card, you can't do this problem because you don't know the chain rule yet. Once you know the chain rule, you won't need to know your note card for this one. I told you how it kind of works. We haven't done any problems. We did one sort of. So on this one, you have to use your note card for your first step, so you have to simplify it. I call on Lewis. Nice. It's an odd function, so it's going to be a negative tangent. And that's an even function, so it's going to be plus secant. That's even and odd properties. That comes up a lot. The only even ones are cosine and secant. Okay? I thought you said cosecant and secant. Cosine and secant, correct. Now you can take the derivatives. Nick, what's going to be the derivative of negative tangent? It's okay, it's right in front of you on your notes. What's the derivative of tangent? Excellent. And what's the derivative of secant going to be? Kaylee? Yeah, tangent x, secant x. So in this case, tangent z, secant z. And there you go. That's how it works.
You don't want to find anymore.
Well, I mean, even if you factor out a secant, you're not solving it. If you're saying it equals 0, yes, you want to start factoring it. But if you're just taking the derivative, that's probably fine. Okay? There's no denominator like we have with the negative exponents. There's none of that. Like I said, you're not solving it. So could you write that a different way? Sure. I mean, negative secant squared is the same thing as negative 1 minus tangent squared if you want to put that in. But you don't have to. Okay? But the even and the odds, that comes up a lot, especially in integrals the second semester. That comes up a lot, the even and odds. Okay? Woo, that was easy. This is going to be a piece of cake. Yeah, here we go. It is. This is also, if you don't have your graphing, or if you don't have your unit circle, I don't think you can do it. I don't think so. Maybe. First of all, find the equation of the tangent line and the normal line. What's the normal line? Sure we have. In fact, the person that just talked about it just walked right by. No. Perpendicular to what? Very good. It's perpendicular to the tangent line. So the normal line is perpendicular to the tangent. That is warranted for a note to self. That the perpendicular line to the tangent is called the normal. So when you find the slope of the tangent line, the opposite reciprocal is the normal line. Did you write that down? Good. The tangent line is equal to the f prime of x, right? How about for f prime of a? That equals the tangent line. The normal line equals the opposite reciprocal of the tangent, or negative 1 over f prime of a. A is like the x value that you're finding the equation or the point. So in this case, A is pi over 4. An easier question is, what is the function value of pi over 4? You were very good with the unit circle, Stephanie. Do you remember what the cosecant of pi over 4 was? Yeah, if I put pi over 4 in, what's the y value going to be? Right, you rationalize it, you end up with root 2. So the cosecant of pi over 4 is root 2. What's the cotangent of pi over 4?
like square root of 2 over 1. Yeah, 1.
It is 1. Nice! See, that didn't hurt too bad, did it? Just kind of step back in time a little bit. Yeah? We have to find the equation of two lines. So we need to find the slope. We need to find the y value when we already have the x value. You have to find all those. So I decided to dust off a little bit and find the y value first, which is the square root of 2 plus 1. And that is on the graph, so we're in good shape there. Right. Yeah, exactly. It means function value. So that's what Stephanie and William just came up with. So, what is the derivative of f of x? Michelle, what do you think?
Negative cotangent x cosecant x plus negative cosecant squared x.
Right. Did you write that down? The derivative of cosecant is negative cosecant cotangent, and the derivative of cotangent is negative cosecant squared. It is. So how do you find the slope of the tangent line? You put in pi over 4 for x. If you put in pi over 4, what's... Oh, we already know the cosecant of pi over 4, don't we? Root 2. We already know the cotangent of pi over 4 is 1. Do you remember how to deal with cosecant squared of pi over 4? Yeah, you have to square the value. Yeah, and the value is root 2, so you square it, you end up with just 2, won't you? So that means the slope of the tangent line is negative root 2 minus 2. All right. Yeah. So we got the y value. We got the x value. We have the derivative. We can find the equation of a tangent line, but this is where there's a small, slight change of plans. Because of all the exact values that have two expressions in them, or two terms, I probably won't use the y equals mx plus b. I'll probably use the point slope formula. You remember what that is? You remember? Remember? Point slope formula. It might be. If not, you're going to need it. The point slope formula is y minus y1 equals, no, m times x minus x1. Yeah. Sure. Y minus y1. This point slope formula. Y minus y1 equals m times x minus x1. Okay? So we know the slope of the tangent line is negative root 2 minus 2. Oh, speaking of that, what's the slope of the normal line? Yeah, negative 1. So what is negative 1 over negative root 2 minus 2? Yeah, 1 over root 2 plus 2, isn't it? So that's the slope of the normal line, 1 over root 2 plus 2. So I got both slopes. I've got the same x and y value for both lines. I'm ready to write two equations. Okay? On the test and on the quiz, you have to keep straight what's the normal, what's the tangent line. You have to keep that straight. We're still trying to find the two equations of the two lines. No, yeah, you don't really have to. No, you don't. You don't have to rationalize it. Because it's the opposite, so I take the opposite of my tangent, and then I take the reciprocal of it. Okay? Opposite reciprocal. And the reason I chose to use the point slope formula is You don't really have to simplify it when you're done. It just says the equation of a line. It doesn't say you have to put the line in y equals mx plus b form. So, first one, let's do the tangent. I just put in the y1 value, and I'm done. Isn't that nice? There we go. Woo woo. Look at that answer. That's an answer.
Where did you get?
It is.
It's y.
y1. That's the y value.
Oh.
Here's the x value, pi over 4. It is. I checked. I Googled it. I did. I said, Google me the equation of a tangent line, normal line, of the equation cosecant of x plus cotangent of x at the point pi over 4, f of pi over 4. I got that. Yeah, that's why I showed this to you. This is where you say thank you. Thanks. This is the tangent line. Yep. You could, but you're not going to graph it out anyway. No, so how do you find the slope of the normal line, or the equation of the normal line? Yeah, except you're going to use this, and you're done. I only use the point slope formula when I'm using exact values and there's a lot of radicals. Other than that, I would still use y equals mx plus b. It's easier to work with, it's much more compact, and you get a cleaner answer. Okay? But that's fine. That was.
You don't want us to solve those and actually find the line.
Well, I mean, if you're going to graph it out, yes, but just as the equation of a line, and the point slope formula is an equation of a line. Okay? I just wanted to bring that up because I don't know when the last time you saw the point slope formula. I don't use that in pre-calc. I'm not sure, did they use it in Algebra 2?
Nope.
Algebra 1?
Nope.
Somebody had to use it at some point in time.
I remember that.
Great! I'm almost done. No, thank me. All right, ready? 2 more, and then I'll call it quits. Ah. Don't be taking this play off. Let's go. No, it's actually connecting. The dendrites in your brain are actually making small little connections with the calculus highway. Zoom! Right now there's a mountain of trees. I'm trying to clear cut it and build a road.
What did you think I said?
No, Graham whispered something to Grizz. Nope, they're laughing because they don't know how to do this. How many answers do you think are going to be on this graph
2.
where the slope of the tangent line equals 0? 2. Here and here. You guys ready? No, it's not those two. You guys ready?
What's the question?
Excellent! How do you find where it's going to be tangent line equals 0? Chase. It says, find the points at which the tangent line is horizontal. F prime A is tangent. How do you find the points? Set equals 0. What's the derivative of cosine? Bert? Good. What's the derivative of negative sine? Okay. Cosine. It is. So I'm going to take the derivative, and as Chase said, set it equal to 0. And I'm going to solve it. And you had this problem in Trig. I made sure you saw it at least 10 times on tests, quizzes, and homework. So when you got to this point, you'd say, I know how to solve that. And the answer is, all I have to do is pick the right person. It could be. Do you want me to pick you? I will pick you. Take a look at how to read this equation. Negative sine minus cosine equals 0. That means sine and cosines have to be opposites, don't they? Where are sine and cosine opposites out in the unit circle? Yeah. No, they didn't know. They're just mumbling. Or exhaling. And we're at. Yeah, what's the point? What's the radian angle measure? Close? Scooch a little bit. 3 pi over 4 and 7 pi over 4. If they're opposites and you add them, you get 0. If they're opposites and you subtract, you get 0.
What were they 3 pi over 4?
7 pi over 4. And I don't have to put the plus. Oh, if you forgot, you can do tangent of x equals -1, same thing. You don't have to put the plus 2 pi in because you're only going from 0 to 2 pi. Here comes the best part. What? Oh, some people added it over and divided. Ended up with tangent equals -1. That's how some people did it. Okay? Some people just like to think about it. Who was the great thinker that put their fist like, oh, it was Bach. He'd always do this and think. Like that statue. He always tried to emulate that. All right. He never had a great thought, but don't tell him I said that. Divided by cosine, actually. Sine over cosine is tangent. Ready? Those are the x values. The question says find the points. So this is where Abigail gets to answer a question. If x equals 3 pi over 4, what's the y value going to be? She's looking for it, yes? Yellow has it? Oh! It's on the floor. What's the cosine of 3 pi over 4? -√2/2. What's the sine of 3 pi over 4? So you have -√2/2 minus √2/2, which turns out to be what? -√2, isn't it? Yeah. -√2. What about 7 pi over 4? What do you think that was going to be? Positive √2. And those are your answers. No, one more I said after this. And then I'll preview the quiz for tomorrow. What? Something. All right. Tangent line horizontal. Great shape.
Okay.
Okay, last one.
This one easier.
It is. This is a great unit circle question. F of x equals x plus sine of x. Find the x coordinates of all points on the graph which the tangent line is horizontal. We've been doing that. Graham. What's the derivative of f of x? That's the first time I said it. What's the derivative? Yep. Good. Next time Rachel can't help you though. So, what does it mean a tangent line is horizontal? Yeah, you said it equal to 0. We've had that question probably 4 times now. Tangent line horizontal means the derivative has a 0 for its value. Where on the unit circle will cosine of x equal -1? Pi. The question says find all the x coordinates at which it's horizontal. We just found at pi plus 2 pi n. Remember, if there's no interval, you have to tack on the general solution, the counter, the things that counts all the pi answers. We talked about that a lot last year. That's because there's no interval. Okay, that's part A. Part B, find the equation and tangent line at the graph. We opened class with one of these problems. Well, not open, I think it was the third one. Where you put pi over 2 in, you find the y, you find the slope, and you can write it using point slope formula, can't you? Okay, that's what we're going to do next. Any questions on part A? Setting the derivative equals 0 and solving? Remember, on the unit circle, the cosine is the x-coordinate. Okay? The sine's the y-coordinate. I think we're ready to move on. Part B. Put in pi over 2. Now, what's the sine of pi over 2? Do you remember? Yeah, it's 1. So those are y-coordinate. The derivative we've already taken is 1 plus cosine of x, right? So that means the slope of the tangent line is going to be what? What is it, Matthew? Pi over 2 and for x.
Yeah, put it in.
I asked, what do you get? You know the cosine of pi over 2. Nope. Cosine of pi over 2 is 0, but the answer is going to be just 1. Good, jot that down. What is the equation for the point slope formula? Yep. Yeah, so I'm going to take y minus pi over 2 plus 1 equals 1 times pi over 2, or x minus pi over 2, the point slope. Oh, this one I did y equals mx plus b. Oh, because it'll cancel out. Now you could go the other way too. This one has a nice and clean answer, though, y equals x plus 1. Yeah. Because I knew if I subtracted the y and the x that they would subtract off, since the slope was 1. You could do it the other way also. Y minus pi over 2 plus 1 equals 1 times pi over 2 times x minus 1 times x minus pi over 2. You could have had that other answer as well. Very flexible in the solutions. Quiz time. Time to preview the quiz, right? All right. I like this part. All right.
Take-home test.
Take-home test.
Let's take it home.
You sound like Prather.